Alright, so for my presentation, I've decided to show the sodium-potassium pump here. For, I guess, my fun way of showing it, I'm an ice hockey fan, so I've decided to kind of compare it to that as an analogy, so hopefully that makes sense. So basically what I drew here is we have your three sodiums currently inside of the cell. And then right here, I drew the plasma membrane with the pump in the middle, and that's going to signify our blue line in hockey. And then right here, we have one ATP, and that's going to represent our hockey puck in this analogy. And then we have our two potassiums, which are currently outside the cell. The two potassiums are going to represent our two defensive players, and then the three sodiums are going to represent the three offensive players in the game. So basically what's going to happen is the sodium-potassium pump, the three sodiums are going to bind to the pump with ATP, and then what's going to happen is the pump is going to change shape, and the three sodiums are going to go outside of the cell, while at the same time the two potassiums are going to be entering the cell. So to compare that to hockey, basically, the sodiums, or the three offensive players, can't enter the zone without the puck. So the three sodiums can't enter outside of the cell without ATP. And then at the same time, the two defensive players are trying to leave their zone or get inside of the cell. So hopefully that makes sense. And then a couple of fun facts that I found about the sodium-potassium pump are that the kidneys are one of the main sodium-potassium pumps in the body that help us maintain sodium and potassium balances. And then the sodium-potassium pump is also responsible in maintaining blood pressure and a steady heartbeat.